Let's do some problems related to area of a triangle and volume of a tetrahedron. Okay, first problem is find the area of a triangle whose vertices are, let's say, the first one. A is 2, 5 minus 4. B is minus 1, 4 minus 3. And C is 4, 7 minus 6. Okay. Now, how do we figure out the area? But first, let's figure out the vectors AB, BC, and AC. Right? Any two of them will also do. Why? Because we know that the area of a triangle, let's say ABC, is equal to half of the magnitude of the cross product of any of the two sides. Let's say AB and cross product. So cross BC, right? This will give us the area. So first let's figure out AB. AB would be minus 1 minus 2, 4 minus 5 minus 3 minus 4, that is plus 4, which is equal to minus 3 minus 1, 1. Similarly, BC would be 4 minus 1, 7 minus 4 minus 6 minus 3, that is plus 3. So this would be 5, 3 minus 3. Yes. So now let's figure out the area. So area is equal to half of the cross product. Now cross product, how do we figure out? Cross product we figure out by using or evaluating the determinant. So that is I, J, K. And here we will have minus 3, minus 1, 1 and 5, 3, minus 3. Okay. Let's figure out this. The determinant would be now here we are interested in the magnitude of this. So let me first evaluate. Let me not include half. Let's evaluate the determinant first. Yes. So first let's evaluate AB cross BC, right? So I times minus 1 minus 3 is 3 minus 3. Minus j times minus 3 minus 3 is 9 minus 5 plus k times again minus 9 minus plus 5, which is equal to, this becomes 0, minus 4j minus 4k. Yes. Now we have to figure out the area. Area would be half of the magnitude of AB cross BC. Yes. So which means half of, now the magnitude of AB cross BC would be the magnitude of this. So magnitude of that would be minus 4 square plus minus 4 square, which is equal to 1 by 2, 16 plus 16, which is square root of 32 by 2, which is 16 2's 32. So 4 root 2 by 2, which is equal to 2 root. So 2 root 2 is the area. So square units, whatever it is. Yes. So here we have to remember this, that AB cross BC is one step. Then evaluating the magnitude of that is the second step, and then taking half of it will give you the area. Okay, let's do another one. Now here A is 1 1 2, B is 2 1 1, C is equal to 0 0 0. Now we know, now we can do much faster, right? So AB, take any two sides. AB is equal to 2 minus 1, 1 minus 1, 1 minus 2, which gives us 1 0 minus 1. Similarly, let's say BC. BC gives us 0 minus 2, 0 minus 1, 0 minus 1, which is equal to minus 2, minus 1, minus 1. Now, AB cross BC would be the determinant IJK. Yes, IJK, then 1, 0, minus 1, minus 2, minus 1, minus 1. This would give us I times 0 minus times minus times minus. So minus 1 minus j times minus 1 minus into minus, that is minus 2, plus k times that will give you minus 1 plus 0, which is equal to minus I minus 3 plus 3j minus k. Now the magnitude of this and half of that would give you the area. So that would give you 1 by 2 times minus 1 square plus 3 square minus 1 plus minus 1 square, which is equal to 1 by 2, 1 plus 9 plus 1, which is equal to 1 by 2 root 11 square units. Yes. Okay, now let's do a slightly different type of problem. Show that the points A minus 2, 3, 5, B 1, 2, 3, and C 7, 0, minus 1 are collinear. Yes. Now, when will they be collinear? See, two points will always be collinear, right? Okay, but the moment you add a third line, right? So here you have 1 point, they will always be collinear. But the moment you introduce a third point, it will be collinear only when it doesn't cover any area. Yes. So a straight line covers 0 area. So therefore, let's figure out the area and equate it to 0, or rather let's evaluate the area. If the area is 0, then it is collinear. So AB is equal to 1 minus minus 2, that is 3, 2 minus 3 is minus 1, 3 minus 5 is minus 2. BC is equal to 7 minus 1, 6, 0 minus 2 is minus 2, minus 1 minus 3 is minus 4. Okay, so now first let's look at AB cross BC. This would give us IJK 3 minus 1 minus 2, 6 minus 2 minus 4. Now whenever you are evaluating determinants, if you remember the properties of determinants, then you would know that if one of the rows is a multiple of another row, then the determinant is 0. Yes. So here, if you look at it, 3 times 2 is 6, minus 1 times 2 is minus 2, minus 2 times 2 is minus 1. So third row is the multiple of the second row. So therefore, AB cross AC is equal to 0. Now, if this is 0, the magnitude is 0, and which means that the half of that will also be 0, right? So area is equal to this is equal to 0. So therefore, we can say A, B, C are collinear. Yes. Okay. Now let's do another one. Find A and B such that the points A is A11, B which is 1B minus 1, and C which is 2, 3 minus 3 are collinear. So we have to figure out the values of A and B in such a way that the values are such that these 3 points are collinear. So very similar to the previous problems, but a little bit twisted. So let's actually do this. Okay. Now AB is equal to AB is equal to 1 minus A, B minus 1, and minus 1 that is minus 2. Okay. BC is equal to 2 minus 1. So let's write 1 itself. 2 minus 1, 1. 3 minus B. Minus 3 minus 1, that is minus 3 plus 1 is minus. Now remember, since we are given 3 points, and to prove that they are collinear, we are looking at it as a triangle. If the area is 0, that means they are all in a straight line. Now to evaluate that, we require only two sides of the triangle. So let's evaluate AB cross BC. Yes. And we have to see that it is equal to 0. If it is equal to 0, that means it is collinear. Right? Okay. So basically, let me write it fully. Okay. So let's first take AB cross BC. Okay. So I, J, K. 1 minus A, B minus 1 minus 2. That is AB. BC is 1, 3 minus B minus 2. Okay, now this, here half can't be 0. If the AB cross BC has some value, its magnitude would be the value itself without the sign. So that means the only option that is left is for this cross product to be 0. That means this should be equal to 0. Now when will this be equal to 0? Remember in the previous example I mentioned that if one of the rows is a multiple of another row, then the determinant is 0. So here if you notice this and this both are same, right? That means you can take in any way. Let's say this row, second row is a multiple of third row, and multiple is what? 1. So minus 2 times 1 is equal to minus 2, right? So similarly what we'll do is 1 minus A times 1 is equal to 1, this one, right? So this would be what? This would be actually bracket. So 1 minus A equal to 1, minus A is equal to 0. That means A is equal to 0. Then this also has to be a multiple. So B minus 1 times 1 is equal to 3 minus, yes. So B minus 1 is equal to 3 minus B, and let's take, now let's do simple algebra. This becomes 2B is equal to 4. B is equal to 4 by 2, that is, so therefore A is equal to 0 and B is equal to 2 for the points to be collinear. Yes. Okay, let's do the next one. Find the volume of the tetrahedron formed by the points. And what are the points? A 1 minus 1 1, B 0 1 2, C 3 1 0, D 1 4 minus 1. Now again we know the volume. What is the formula? Yes, 1 by 6 A B A C A D. Yes, just to be clear, vectors. Okay, let's do this. Now here, first we have to find out AB. So AB is equal to minus 1, 1 minus minus 1, that is 2, 2 minus 1 is 1. So AB is this. AC is equal to 3 minus 1, that is 2, 1 minus minus 1, that is 2, and 0 minus 1, that is minus 1. Okay, AD is equal to 1 minus 1 0, 4 minus minus 1, that is 5, minus 1 minus 1 minus 2. Okay, now let's figure out the volume. Volume is equal to 1 by 6, and let's put this minus 1 to 1, 2 2 minus 1, 0 5 minus 2, and this is pretty straightforward. Minus 1 times minus 4 minus minus, so plus 5, minus 2 times minus 4 plus 0, then plus 1 times 10 minus 0, which is equal to 1 by 6 times 5 minus 4 is 1, so minus 1, 4 2's 8, so plus 8 plus 10, which is equal to 8 plus 10 18, 18 minus 1 17, so 17 by 6. Volume, so this is not going to be square, it will be cubic units. Okay, now finally let's do the last question. Find A such that the following points are coplanar. Yes, so let's say you have 4 points. So if they are on the same plane, that means what? They will be having volume as 0, right? Now to find the value of A such that the points are coplanar, we assume that they are coplanar, in which case volume equal to 0, and then we evaluate A. First let me write down the points. A 3 2 1, B is 4, A 5, C is equal to 4 2 minus 2, and D is equal to 6 5 minus 1. AB is equal to 4 minus 3, A minus 2, 5 minus 1, which is equal to 1, A minus 2 and 4. Okay, AC is equal to 4 minus 3, 2 minus 2, minus 2 minus 1, which is equal to 1, 0 minus 3. And finally AD, which is 6 minus 3, 5 minus 2, minus 1 minus 1, which is equal to 3, 3 minus 2. So now volume is equal to 1 by 6 of the determinant of this 3 by 3 matrix. 1, A minus 2, 5 minus 1, 5 minus 1, 4. 1, 0 minus 3, 3, 3 minus 2. Yes, so what we have been asked to do is to figure out A such that the points are coplanar. That means volume has to be equal to 0 for it to be coplanar. So, which means 1 by 6 times. Now we have to figure out the determinant. 1 times 0 plus 9 minus a minus 2. A minus 2 times minus 2 minus that is plus 9. Minus 2 plus 9 is 7. Then plus 4 times 3 minus 0 equal to 0, which implies 1 by 6, 9 minus 7 times a minus 2 plus 12 equal to 0. Now 1 by 6, if we take it to the other side, it will disappear. So we could have done it earlier itself. Now 9 minus 7a minus plus 14 plus 12 equal to 0. 14 plus 12 is 26. 26 plus 9 is 35. So minus 7a is equal to minus 35, which is equal to a equal to 5. So a has to be equal to 5 for those 4 points to be coplanar, right? So that is evaluating areas of triangle and volumes of tetrahedron. That's it for today. Bye for